Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Musa Zulu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Okay, grade 12, today our knowledge area has changed from mechanics that we've been doing for the past 3 weeks. And today we are doing matter and material. So today our knowledge area is on matter and material. And our topic of focus today, we are introducing this topic here, organic chemistry. So we are going to be focusing on organic chemistry for today, and we'll try to introduce it, and we'll take it from there. Okay, so matter and material is a knowledge area that is found in paper 2, together with organic chemistry. So it is important that we know the structure of paper 2 as we have been looking at the structure of paper 1 when we were doing paper 1. So the structure of the paper is as follows. Paper 2 consists of 2 sections. Section A, and section A has 5 multiple choice questions, and these 5 multiple choice questions have a total of marks of 10 marks. Section B is your structured or long questions, and these questions are out of 65 marks. The total of paper 2 in technical science is 75 marks. And we write this for a duration of 1.5 hours or 1.5 hours. So this is our structure, and it is extremely important that we familiarize ourselves with the structure of the paper. We know how the paper is going to be structured like. So organic chemistry, we will find it in multiple choice questions, obviously, in the first 2 or 3 multiple choice questions. That would be 1.1, 1.2, and maybe 1.3. But the structured questions for organic chemistry will be question 2, question 3, and question 4 most of the time. Depending on each question, it can be question 2, 3, 4, or it can be question 2, 3, 4, and 5, depending on how that specific question paper is structured. But usually, you will find it being question 2, usually in question 3 and question 4. So that's how we want or the paper 2 is structured, and that's how we want to know it as learners. All right. So before we can even dive into organic chemistry grade 12, we need to familiarize ourselves with the periodic table of elements. Now, we're not going to go deep into the periodic table of elements. We're just going to focus on what we are going to need, especially for organic chemistry and especially for today's lessons. Now, in our periodic table of elements, we are going to use the following elements. We are going to be looking at the element carbon, which is said to be in group 4, and that is going to be important, especially for today's lesson. So we say it is in group 4, right? And we're also going to look at hydrogen, right? And then also we are going to look at oxygen, and then we are going to look at these elements here in group 7, and the name of the elements in group 7 are said to be halogens. These are said to be halogens. It is important that we know that these elements are called halogens, and this is going to come handy later on. And the following elements that we are going to look at as halogens are the following: fluorine, chlorine, bromine, and iodine. These are the elements that we are going to focus on as our halogens for us to be able to know organic chemistry, at least at an introductory level. All right. So, what are organic molecules? Okay. It is important that we are able to define this term organic molecules. How do we define organic molecules? We define organic molecules as molecules containing carbon atoms. These are defined as what? Organic molecules containing carbon atoms. This is a formal definition in grade 12. It's a formal definition that comes from your exam guideline. As I've been saying this over and over, we define according to the examination guideline. So one of the definitions that come in the examination guideline is that of organic molecules. And we say organic molecules are molecules containing carbon atoms. As we have seen there, that carbon atom is highlighted in red. That shows us that the carbon atom we are talking about is important and is special when we are talking organic molecule. Okay, all right. So now looking at the definition itself, molecules containing carbon atoms, that tells us that we are going to have a special atom here in our organic molecules, and the special atom is going to be what? Carbon. This means that the carbon is going to be central in all organic molecules, meaning that all organic molecules are going to be centered around the atom carbon. All organic molecules will be centered around the atom carbon. So carbon becomes very special when we are talking about organic molecule. Now, why is this carbon becoming very special? Well, we're not going to go too much into too much details about it. We're just going to brush at a surface, and what is our focus is going to be, grade 12, is we're going to mainly focus on the things that we need to know for our level. We're not going to focus too much on the deeper organic chemistry, because organic chemistry can be a broad topic. It can be a broad subject. So we're not going to go deeper into it, and we're also not going to go too much back to where we are supposed to be back, right? What we're going to do is just simply focus on what we need to know for our grade because of time constraints. So we say carbon has the ability to form long carbon-to-carbon chain. So carbon has this ability of bonding or reacting with other carbons and form long carbon-to-carbon chain. This is a special ability that makes carbon to be special when it comes to organic molecule. That's why we're going to say all organic molecules are going to be centered around carbon. It's because of that special ability that it has, that it can form long carbon-to-carbon chains. Right. So carbon forms these long carbon-to-carbon chain through a bond called what? A covalent bond. So it forms a covalent bond, right, with a lot of molecules or a lot of atoms, I should say. However, as I said, we are going to be specific to what we need to know. Carbon is going to form covalent bond with the following elements for us, grade 12 technical science. It's going to form these covalent bonds with, obviously it will form with other carbon, as we have said, carbon-to-carbon bonds. It will form with other carbons, but it will also form with hydrogen atoms most of the time. You will also find it forming a covalent bond with oxygen atoms. We will also find it forming a covalent bond with chlorine and a bromine. It also forms with fluorine and iodine. However, we are going to be focusing mostly on the chlorine and the bromine because those are the ones that are mostly focused on, again, at our level technical science grade 12. So this brings about the question, what do you mean a covalent bond? What is a covalent bond? Well, you remember that in grade 10, we learned about bonds, but we did not do the covalent bond. In grade 10, we did the ionic bond and we did the metallic bond. In the ionic bond, where we were talking about the transfer of electrons going from one atom to another atom, and the other one becoming positively charged and the other one becoming negatively charged. If you remember grade 10, there was a type of bonding, it was called ionic bonding. We also spoke about metallic bonding when we were talking about delocalized electrons in a metal. We also talked about that, but we have never spoken of a covalent bond. So what we are going to do before we dive into deep organic chemistry, we're going to try and understand what a covalent bond is, because it's important for you to understand covalent bonds and what a bond is in actual fact. So, right, okay. So I will take you back, right? As I've said in the periodic table, as we were looking at the periodic table, we said carbon is in group 4, right? So if we are saying carbon is in group 4, right, what do we say? If you remember in grade 10, we said we have something called valency, right? And then we said, what is this valency? Valency, we said in grade 10, these are the electrons in the outermost shell. These are the electrons in the outermost shell. So group 4 tells us that carbon has a valency of 4, meaning that carbon has 4 electrons in the outermost shell. Right? Bear with me and just try to follow for now, right? You will get it in a moment. So carbon has 4 electrons. Carbon has a lot of electrons in total, but we are mostly interested in the electrons that are in the outermost shell. Why are we interested in the electrons that are in the outermost shell? Because these are the electrons that are involved in bonding. These are the electrons that can be shared. These are the electrons that can be transferred if they are. Right? So we're going to look at that. We're going to say, since carbon is in group 4, it has a valency of what? It has a valency of 4, meaning it has 4 electrons in its outermost shell, right? Okay. Then we go back to hydrogen. We say, okay, hydrogen, in which group is hydrogen? Hydrogen is in group 1. So what does that mean? Hydrogen has a valency of 1. Okay, that means hydrogen has only 1 electron in its outermost shell. Now, if you remember in grade 10, this is how I usually put it, and I hope you follow me. I say carbon is not happy with only 4 electrons in its outermost shell. None of the elements are happy if their outermost shell is not filled, meaning it's not inert. And when is the outermost shell inert? Well, there are 2 options. If the outermost shell is the first shell, it's going to be inert if it has what? If it has 2 electrons in its outermost shell, right? But if the outermost shell, there was the first shell and maybe it is the second shell, it is happy if it has 8 electrons in its outermost shell, meaning that carbon needs 8 electrons to be happy. It needs 8 electrons in its outermost shell. Again, follow me here, right? And then hydrogen, since it only has 1 shell or 1 orbital, right, it needs 2 electrons to be happy. Okay, so both of them, as they are unhappy. Okay, so this carbon, right, as he is, because carbon has this ability of forming carbon-carbon chain, this long carbon-carbon chain. He wants to continue doing this, but he wants to do this and be happy, meaning that he wants to do this with 8 electrons. So what does carbon say? Carbon then approaches hydrogen, says, hydrogen, can you come over and give me your electron? I want that electron. And please bring along 3 of your friends, meaning there's another hydrogen, Bring along 3 of your friends, because carbon knows if he can get 1 electron in each of the hydrogens, then you will have a total of 8 electrons. Is going to be happy in that case. But then hydrogen says to carbon, no, I cannot give you my electron, because as I am, I also need 1 electron. So hydrogen refuses to transfer his or her electrons to carbon. Okay, so then they came up with a plan to say, okay, you know what we're going to do? Let's share the electrons. Let me not be the one who gives to you. I will also not give to me. We are not going to transfer these electrons. Instead, what are we going to do? We're going to share. So we are going to come next to each other or closer to each other, and we're going to put these electrons here next to us. When you need them, you will use them. When I need them, I will also use them. And in the moment they start sharing, now they are doing what is called what? Covalent bonding. Covalent bonding is the sharing of electrons between non-metals to form molecules. So they are going to share these electrons between them as they are non-metals. So instead of transferring, they say you can't transfer. We both want to be happy. We're not only looking for carbon to be happy or hydrogen. Both of us need, because as hydrogen needs only 1, because hydrogen only has 1 orbital. So it needs only 1 electrons to have 2 in it. It's going to be happy. Okay, carbon needs 4. So what does carbon do? Carbon says, I need 4 hydrogen to come to me with their electrons. So each hydrogen is going to come, bring its electron, that 1 electron. Another hydrogen comes, bring its electron. Another hydrogen comes, brings its electron. Another hydrogen comes and brings its electron, right? So these electrons are now shared, meaning that carbon has access to all of these electrons. This hydrogen has access to these 2 electrons. This hydrogen has access to these 2 electrons. Now, once this hydrogen has access to these electrons, it becomes inert, because it means its outermost shell is going to have 2 electrons. This one has access to this one has access to this one. So they have now bonded, and they have now formed what is called a what? A covalent bond, where they are sharing the electrons. No one takes the electrons from the other one. So we are not going to have a case where the electrons is transferred, where one of them is going to become positively charged or negatively charged. No, they are just going to have the same charges, because they are actually sharing the electrons. These electrons are going to be spending some time on hydrogen, they'll be spending some time on carbon. So both of them being happy in this case. Now carbon is happy now. Okay, right. Now, after they have shared these electrons like this, as you have seen how I have represented them, it then becomes unnecessary for me to represent them as electrons. So there's another structure that I can use to represent them, because I now know that 2 electrons are forming a bond. There is a bond there, right? So 2 electrons form a bond. So it then becomes unnecessary for me to say I am going to always write dots, right, to represent the electrons around the carbon and represent the electrons around the hydrogen, because I know those 2 electrons that are there are going to be forming a bond. What I can now do, I can simply write these 2 as what? As lines, knowing in my head that a line represents that there are 2 electrons that are being shared there. And I'm going to write another line here, and I'm going to write another line, I'm going to write another. What I'm trying to do here, grade 12, is show you where these lines that we are drawing in organic chemistry, they are coming from. They are coming from the fact that these atoms were sharing the electrons, right? And from sharing the electrons, they then created a relationship. And this relationship, we call it a bond. And what type of a bond? We call it a covalent bond, because electrons are being shared. So you will see us writing structures and we are using lines, and you are asking yourself where these lines are coming from. They are coming from the fact that electrons are being shared there. So then from moving forward, I no longer need to write these as dots and electrons. I can always just simply write a what? A dash or a line. And I know that this line represents a bond between a hydrogen and a what? And a carbon. This is a bond between a hydrogen and a carbon, a bond between a hydrogen and a carbon, another bond between a hydrogen and a carbon. So instead of talking about electrons, I can now talk about what? I can now talk about bonds to see how many bonds does our carbon have now. Carbon has 4 bonds. I said before, carbon is going to be happy when he has 8 electrons around himself. Now I'm talking of what? Bonds. And 4 bonds make carbon happy. This is very, very important, Krito. This is extremely important. 4 bonds make carbon happy. Carbon is only going to be happy when carbon has 4 bonds around himself. Carbon must always have 4 bonds. So one thing that we must always ensure is that our carbon has 4 bonds. Hydrogen will always have 1 bond because hydrogen only has an option of sharing 1 electron. So hydrogen will always have 1 bond. But it is important that we keep it in our mind that carbon is happy with what? With only 4 bonds. 4 bonds, nothing less, nothing more. Cannot have more than 4, cannot have less than 4. Right. Now, this carbon that has bonded with hydrogen through this interaction they have together doesn't mean that hydrogen is the only thing that carbon can bond with. Carbon can actually call other carbons and say, instead of me calling 3 hydrogen, why don't I call another carbon? So once I have another carbon, I am going to share a bond with this carbon, right? Then that means I need only how many hydrogen? Because already he has a bond here. So because he needs 4 to be happy, how many now does he need? He only now needs what? 3 hydrogens. So that he's going to have what? 4 bonds, right? Then the other carbon now can also do his own interaction with other hydrogens and say, I will need 3 more hydrogens, then I will be happy. So that shows us that carbon can also form bonds with other carbons. That's how actually we get the what? The carbon chains that we were talking about. Not only other carbons, carbon can also form bonds with, but before we go to other atoms, carbon can form what we call double bonds with other carbons. Can actually form double bonds to say, I don't want to have 3 hydrogens. Why don't we as 2 carbons just simply do what? Form double bonds between each other. Let's bond this side and bond the other side. So we are forming what is called there a what? A double bond. So that means now this carbon needs only how many bonds? It only needs 2 bonds. Then it will only call 2 hydrogens. So these are other bonds that could be formed by carbons. Again, carbons can also decide to say, you know what, we are going to form triple bonds with one another. They can decide, we are going to form triple. We're not going to form single bonds or double. We are going to form triple. We are minimizing the number of hydrogens that we are going to need. Once they have formed triple, this carbon has 1, 2, 3 bond. So it only needs 1 more to be happy. Because remember, carbon is happy when carbon has 4 bonds. And then this one is also going to need only 1 hydrogen to be happy. Again, remember, we need what? 4 bonds to be happy because it's 1, 2, 3, 4. So what I'm trying to show you there is the type of bonds that carbon can form. Can form bonds with hydrogen only, can form bonds with other carbons, can form bonds, double bonds with other carbons, can form the triple bonds with other carbons. And I'm going to emphasize again, right? Grade 12, it is impossible for carbon to form a double bond with a hydrogen. This will be completely wrong. It's incorrect. It's impossible for a carbon to form double bond with a what? Hydrogen. Why is that impossible? Hydrogen only needs 1 more electron. So if you make carbon to form a double bond with a hydrogen, what you are saying is that now this hydrogen is now gaining 4 electrons, which does not make sense. This is not true at all. So we will never have a double bond with what? With a hydrogen. So the double bond, you should find it between what? 2 carbon atoms. The triple bond, you should find between 2 carbon atoms. However, Carbon can form bonds with what? With oxygen. Are we together? Right, carbon can form bonds with oxygen. It can form single bonds with oxygen, right? And then the oxygen maybe will be bonded to another hydrogen, and then the other carbon will get other hydrogens in that case. Okay, then it becomes happy, right? Or the carbon can again form double bonds with what? With oxygen. It can form double bonds with oxygen. So double bonds with oxygens are possible. So double bonds are possible with carbon-carbon. Double bonds are possible with an oxygen. Are we together? And carbon can also form a bond with another oxygen. Okay, I hope you remember the elements that I alluded to earlier on that we are going to look at from a periodic table. I said we look at hydrogen, we look at carbon, we've looked at it. I said we look at what? Oxygen. What are we left with? We are left with the halogens. Again, carbon can form bonds with the what? With the halogen. Carbon can simply decide to say, you know what? I am going to just simply call chlorine to come and help me. Chlorine will come in and chlorine will share. If you remember that elements in group 7, they have 7 in their outermost shell, meaning they only need 1 to be happy, if we can look at it like that. So they can share that 1 with carbon, and they will be inert. They will have 8 electrons in the outermost shell. Carbon will also have 8, provided he calls other hydrogens. So it is possible that the carbon can bond with what? One of the halogens. It could be the chlorine, it could be the bromine, the fluorine, and it could also be the iodine. Right. So this is what here we're trying to do here, is to show you how these bonds are and where these bonds are coming from. They're covalent bonds, these ones, and this is where they come from. So from today, I'm expecting that everyone now knows what this line is. It's a bond, and I'm expecting that they know that this bond is a covalent bond. And how does this covalent bond comes about? It comes about the sharing of electrons, because these elements or atoms, they want to be happy, they want to be inert. Inert would be the correct term for it. Happy is what makes sense to me. Okay, he's happy because he's inert. So from today, people know where these lines are coming from. We are no longer just throwing lines, just not knowing where the lines are coming from. Okay, if then we know where the lines are coming from, then maybe we can now start jumping to some organic chemistry. Okay, and I want you to look at organic chemistry as sort of learning a new language. Grade 12. We are learning a new language. So when you're learning a new language, you take it slow, right? Because you don't know a lot about this language. You are hearing things that you are hearing for the first time, a lot of them. So you need to take it slow, right? Calm down, relax. Don't be frustrated, right? Don't allow yourself to be frustrated, because we are learning a new language. And one of the new things that we are going to learn here is these carbon chains that we are talking about, right? As I've said, they can form long carbon chains. However, for us, from in grade 12 technical science, our chain will start from 1 carbon and it will end up to 6 carbons. So we are never going to talk of a carbon chain that is above 6 carbons, right? So we are minimizing that, because remember, what are we doing? Learning a new language. So we want to minimize the amount of stuff that we are learning because of time again. So these numbers now, they become, or they change, because again, we are learning a new language. So 1 to us changes grade 12, right? I'm expecting that no one is going to use 1 now when we are talking organic chemistry language. We are learning a new language. Okay, so when we say 1 carbon, we are no longer going to say 1 carbon, because that's English language. We no longer want to use English language. What do we want to use? We want to use organic chemistry language. So 1 is now going to be what? Myth, right? It's myth. So it will be somewhere in the name when we name these organic compounds, grade 12. That's why it has a dash, because what it is actually, it's a prefix of the actual name of the compound, right? So the name is named based on the number of carbons that are there. If there is 1 carbon, the name will start with myth followed by something else. Okay, but that myth there simply means 1 carbon. Okay, so it's a prefix. That's why I'm putting a dash for now here. Okay, And then 2 carbons is going to be eth. Okay, 3 carbons is prop. New word, I know. 4 carbons, excuse me, is but. We say but, not bad, but but. 5 carbons is pent. Okay, and I think this one should be making a little bit of sense to say pent. It's 5 pent, pentagon, a shape with 5 sides, right? And then 6 carbons is going to be hex. Again, hex, thinking of hexagon, a shape with 6 sides. I know all of you are doing also engineering, graphics, and design, and you sometimes draw that hexagon. It's a shape with 6 sides. So, grade 12, this you must know, even if I wake you up at 2 o'clock in the morning and I say 1 carbon, I'm expecting you to say myth. I say 2 carbons, you say eth. I say 3, you say prop. I say 4, you say beauty. I say 5, you say pent. I say 6, you say hex. This is very, very important to know. It's something that I must wake you up in the middle of the night and you do not have to think about it. It must not be something that you think about it. You must just be able to speak it up. You don't think about walking. You don't think about taking the next step. So I don't want you to think about it. I want it to be second nature like that, like walking to you, that 1 carbon is myth, 2 carbon is eth, 3 carbon is prop, 4 carbon is beauty, 5 carbon is pent, and 6 carbons is hex. It's very, very important. It's the basic knowledge that we need. That's the first thing that we learn in this new language of ours called organic chemistry. Okay. Right. Now, these carbon chains, okay, that are going to be 6 of them, from 1 carbon to 6 carbon, right? Now, they are going to be demarcated, meaning they are going to be put according to groups, certain groups altogether. And these groups, I always look at them as a family. So you are going to have a whole family, right? Another example that I usually make is all of you are doing grade 12, but within grade 12, there is grade 12A, there is grade 12B, there is grade 12C, and there is grade 12D. And all these grade 12s, they differ most of the time in terms of the subjects that they do. So you can identify each grade 12 based on the subject they do. So that's what we are also going to have with this carbon to carbon chain. Some of them will go into this class, some of them will go into this class, some of them will go into a certain class. Okay, now the whole umbrella of all grade 12 we call what? A homologous series. So all these chain, they fit under what? Homologous series. So your homologous series is like your what? Your grade 12. It is a series of organic compounds that can be described by the same general formula and where each member differs from the next by a CH2 group. Now, as we continue with this language of organic chemistry, this is going to make sense. However, what I would ask from you, grade 12, for now is let's go and just memorize this definition, right? As we dive into organic chemistry deeper, it will start making more sense and more sense to see. It's a series of organic compounds that can be described by the same general formula. So they have the same general formula, and where each member differs from the next by a CH2 group. So within that family, each member will be differing by a what? A CH2 group. And then we also must be able to define a functional group. So what is a functional group? Well, the functional group is the subjects now in grade 12. It's how I now identify that these learners are doing these subjects. These learners are grade 12A, they are doing this subject. These learners are grade 12B, they are doing, these ones are doing electrical technology. These ones are doing woodworking. These ones are doing mechanical technology. These ones are doing welding. You know, that's how we divide ourselves. That's how we know ourselves. That's a functional group. Those are the things we use to identify to which class does the learner belong. So if I'm looking at a compound and I want to identify to which homologous does it belong, what I will check is its functional group. Okay? If I'm looking at learners, I want to check to which grade 12 does this learner belong. I have to check the subject. Or you have an electrical technology book, power system, you are doing power system. Or you have a mechanical technology book, you are doing mechanical. Or you have a woodworking book, you are doing woodwork. Or you have this book, you are doing this. That's how I identify to which grade 12 do you belong. So we are also going to be identifying these organic compounds according to which homologous series do they belong. And what we'll be checking is their functional group. And what is a functional group in terms of the formal definition? We say it is an atom or a group of atoms that determines the chemistry of a molecule, right? It's an atom, so it's one atom that you are going to check to see if I see this atom, well, you must be belonging. Like I'm saying, check this book, you must be belonging there. So you are going to check if I see this atom on the compound, oh, then this compound must be belonging to this homologous series. Or if I see this group of atoms, it's an atom or a group of atoms that determines the chemistry of a molecule. So once I see, I'll be looking for those group of atoms. Once I see this group of atoms, then I know that this molecule belongs to which homologous series. Once I see this group of atoms. Another way that you can actually define a functional group is an atom or a group of atom again that determines the physical and chemical properties of an organic compound. Right. So this basically means the same thing as this. I like the first one. I like you to know this one. It's simple. This one, we're saying physical and chemical properties. It's the same thing as saying the chemistry of a molecule. Okay, right. So I like the first one. So I would advise, it's only an advice that you say an atom or a group of atom that determines the chemistry of a molecule. Okay, another definition that I want us to know that I will be talking about a little bit later on is hydrocarbons. Okay, what are hydrocarbons? Well, in definition, we say hydrocarbons are organic compounds, okay, that consist of hydrogen and carbon atoms only. The definition is actually in its name, hydrocarbon. Hydrocarbons, okay, hydrogen, carbons, carbon, atoms only. Only is extremely important, hence it is also highlighted in red there. If you were to be asked to define hydrocarbons, you cannot leave out the only. The only becomes extremely important. Organic compounds that consist of hydrogen and carbon atoms only. Okay, all right. Okay, now what we are going to do, I want us to now go and look at the homologous series that we are talking about. Okay, the homologous series that we are talking about. These are our classes A, B, C, D, E, and then we are also going to check the functional group to say now, how do I know that this compound belongs to A? How do I know that this compound belongs to B? How do I know that this compound belongs to C? It's a functional group. And for today, I want us to focus mainly on the name of the homologous series and also the structure of the functional group to say, if I'm looking at the structure, what is it that I look for that tells me that this compound belongs to this homologous series? So again, grade 12, we have a homologous series, we have a functional group. A functional group tells me to which homologous series does a compound belong. So let's go and look at our homologous series. Our homologous series, we have 9 of them. We have 9 homologous series, and they go as follows. The first ones are called alkanes. As you can see here, homologous series. The first ones are called alkanes. Okay. Now, what is the functional group of alkanes, or the structure of the functional group of alkanes? Alkanes will have single bonds between the carbon atoms, and they will only be bonded to hydrogens. So they will consist of only single bonds between the carbon atoms, and then the carbons will only be bonded to hydrogen. So the other atoms that will be there will only be hydrogen. So that's how I identify an alkane. So how do you identify an alkane? By looking at the bonds between the carbon atoms. Are they single? Yes, they are. What are other atoms that are there? It's only hydrogen. So I know that this is an alkane. So if I have maybe a structure that looks like this, okay, a structure that looks like this, making sure that all carbons are happy, okay, how do I conclude that this structure is an alkane? I would say it is an alkane because there are only single bonds between carbon atoms and all the carbons are bonded to only hydrogen atom. I hope that rings a bell with something that we have just defined. Hydrocarbons, carbons containing hydrogen and carbon atoms only. Okay, the second homologous series is known as alkenes. Alkenes, how do we see alkenes? What is their functional group? Remember, what does the functional group do? It tells us to which homologous series does the compound belong. Okay, how will I know if a homologous series belongs on alkenes? If immediately I see a double bond between carbon atoms. Doesn't have to be a double bond between all carbon atoms. It could be just at least one double bond between carbon atoms. At least one double bond, and that double bond must be between carbon atoms. So it must be a carbon-carbon double bond. Immediately I see that, then I know that that compound belongs to alkenes. I hope this is making sense, and I hope it is making this new language thing that we are learning easy. All I look for is, are they single bonds? All I look for is, are they double bonds, right? And for alkynes, which is the third type, we look for what? Triple bond. If we have this here, we look for double, and here we look for triple bonds. If we have triple bonds between the carbon atoms, then we are going to say these are what? These are alkynes. Alkynes, they have triple bonds between carbon atoms. They are also going to be only bonded to hydrogen atoms only. These ones will only also be bonded to hydrogen atoms only. So they have double bond bonded to other hydrogen, and the other atom will be hydrogen atoms. These ones have triple bond, and the other atoms will only be hydrogens. So what does that make them again? All three of them, it makes them to be what? Hydrocarbons that we talked about. Hydrocarbons. These are organic compounds containing hydrogen and carbon atoms only. There is no other atom here that you will find in alkanes, alkenes, and alkynes. Okay, all right. Then our next one is what we call haloalkanes. Okay, what are haloalkanes? Well, haloalkanes, their structure is a homologous series, yes, but the structure of the functional group there, we will see a carbon, right? It will be bonded to either hydrogen, of course, but one of the atoms that should be there is one of the what? Of the halogens that I said in the beginning are going to become important. Halogens. It is going to be one of the halogens. So what are those halogens? It could be chlorine. I'll start with chlorine, bromine. These are the ones that are spoken of mostly for us grade 12. The chlorine, the bromine. However, it is possible that we are also asked of the fluorine and also of the iodine, because these ones are also halogens. Okay, so it could be any of these ones. Once I see any of these ones in any organic compound, then I say that organic compound belongs to haloalkane. Once I see any of these ones in any organic compound, then I can safely say that organic compound belongs to haloalkane. Remember, it's a homologous series, it's a functional group. Okay, I use a functional group to tell me to what homologous series does a certain compound belong. So I check this compound, I say this compound has this group of atoms. Well, this group of atoms tells me that this compound belongs to this homologous series. So if I am looking for a compound that belongs to haloalkane, the atoms or atom I will be looking for is one of the halogen. At least one. It could be more than one. Right. The next one is then alcohols. Alcohols, grade 12, is a homologous series. Alcohol is a homologous series in organic chemistry. Okay. What will I look for me to be able to determine that this compound is an alcohol? I will simply look for NOH. I will simply look for what? NOH, where I will be having an oxygen bonded to a carbon with a single bond, right? I should stress that. It will be a single bond from a carbon to an oxygen and a single bond from oxygen to a hydrogen. That makes it alcohol. And there must be a bond between oxygen and the what? And the hydrogen. So once I see this and only this, then I say it is alcohol. Are we together? I hope we're together. The great talk. Only when I see this and only this, then I can say that it is what? It is an alcohol. O bonded to hydrogen. And it must be only. I'll tell you later on, you realize later on why I'm stressing that it must only be O bonded to hydrogen, single bonded to carbon. Okay, then I say this is the what? This the name of this functional group. It has a name. It is called a hydroxyl group because of this hydroxide that is attached to this organic compound. We call this a hydroxide. So it makes it a hydroxyl group. Okay, so it is also important that we know the names, even though that's not why I would like us to be focusing mostly for, especially for today, because I still want us to understand just the basic of this organic chemistry. You see, let's look more on the structure, because my belief is that when it comes to organic chemistry, the structure rules everything. If a person can do structures, understand structures, everything else becomes secondary or even tertiary after that point. Okay, as we continue, the next one is aldehydes. And how do we see aldehydes? Well, aldehydes, we are going to have a carbon bonded to an oxygen, but there will be a double bond. I hope you now see the difference between that one. And this oxygen will not be bonded to another hydrogen. This oxygen will not be bonded to another hydrogen. And this carbon that is bonded to oxygen will always be carbon 1. It will always be on carbon number 1 for an aldehyde. And again, it's important. It is very, very important for us to realize that it will be in carbon number 1, because once it shifts from carbon number 1, that is no longer an aldehyde compound. It becomes something else. Okay, so in aldehyde, we see it by a functional group of what? A carbon bonded to an oxygen, double bonded to an oxygen, by the way. Okay, and that carbon that is double bonded to an oxygen will be carbon number 1. Okay, the next one there becomes ketone. Okay, in the ketone here, we are having a carbon double bonded to oxygen, again, like an aldehyde. We are having a carbon double bonded to what? To oxygen again. But what is the difference here? The difference is that the double bonded oxygen carbon here, or the carbon that is double bonded to oxygen, is not carbon number 1. It is a carbon that is in between 2 other carbons. So here it is always going to be what? Between 2 other carbons. That's how you are going to see. That's a ketone. The moment you see a carbon bonded to a double bond oxygen and it is between or surrounded by 2 other carbons, then you can say that this is a ketone. That's why I was saying here on an aldehyde, it's important that to remember that this one will always be on carbon number 1. So if it's on carbon number 1, it's an aldehyde. Once it shifts from carbon number 1, it does not become an aldehyde. It now becomes a what? A ketone, because then it will be surrounded by 2 other carbons. Okay, right. The next one then becomes a carboxylic acid. But before then, I just want you to just take note of this and just look at this. Okay, you can see that these 2 people have similarities. These 2 people have similarities. What I usually call them, I call them friends. There are similarities that I want you to take note of, so that when it is time for us to speak about them, you remember that we spoke about a little bit about them before. There are similarities, and what is the similarities? Both have a what? A double bond O. A double bond O here. both of them. The only difference is the position of the double bond O. Here it's on carbon number 1, here it's on carbon number 2. So they have similarities. So I usually refer to them as friends. I say they are friends, these ones, they have similarities. And there's another word that I will be introducing to say, what do we mean when we say they are friends? The name of the aldehyde, the functional group of the aldehyde is called the what? A formal group. While the name of the functional group of the ketones is called the what? Carbonyl group. These are questions that are also again asked in an exam. Write down the name of the functional group of compound A. And when you check that compound A, it's a compound that belongs to ketones. Then you say the functional group should be what? A carbonyl. Right. As I move on to the next one, we talk of carboxylic acid. What do we say about carboxylic acid? We look at the structure of their functional group or its functional group. We say it's going to be what? A double bond O, okay? Then we are going to also have an OH, okay? That is why when I was speaking of alcohols, I said here on alcohols, I said it is only OH, only. So that's the difference here. On alcohols, it's only OH. But when you look at the carboxylic acid, it's OH, but there's also a double bond O. So you must be careful. That tells you that you must be very, very content with your stuff. You must know your stuff. You must know how to differentiate one from the other here. So they are going to have a double bond O. I usually call it double bond O. Double bond O, because you have this double bond O, then you have another O. Then it is connected to what? To a hydrogen. And this, again, like the aldehyde, will always be on carbon number 1. It will always be on carbon number 1. For it to be a carboxylic acid, it must be on carbon number 1. Moment it moves from carbon number 1, it's no longer a carboxylic acid. So that's one of the way. I believe it makes it very, very easy to identify a carboxylic acid, because I'm just looking for double bond OO. And where am I looking for the double bond OO? I'm looking for it on carbon number 1. So that's how I will see that this compound belongs on carboxylic acid. And the name of their functional group becomes carboxyl, a carboxyl group. Okay, and then the last one that we are going to do here is esters. We do esters here. And how do we see esters? By looking at their structure. Well, we say esters are also going to have a double bond OO, like the carboxylic acid, right? They are also going to have a what? A double bond OO. The difference is that this double bond OO on esters is going to be between 2 other carbons. So it will be surrounded by 2 other carbons, as was the case on ketones. I don't know if anyone sees these similarities between all these 4 things. Yeah, right? On carbon number 1, between 2 other carbons. On carbon number 1, again, between 2 other carbons. Here it's double bond O, double bond O. Here, double bond OO, double bond OO. O standing for oxygen, by the way. So here it's going to be what? Between 2 other carbons. Going to be between 2 other carbons. So that's how you see that this is an ester. Once you see a double bond OO. So what am I looking for? I'm looking for a double bond OO. Where is the double bond OO? It's on carbon number 1. O, that's a carboxylic acid. If I say I'm looking for a double bond OO, where am I finding it? I'm finding it between 2 other carbons. Well, that is an ester. So that's how you are going to determine whether we are talking about an ester, whether we're talking about a carboxylic acid, whether we're talking about a ketone, whether we're talking about an aldehyde. All right? As you can see again here, we are having similarities, which tells me that carboxylic and esters must be friends. They must be having some sort of a relationship. These people are similar. They are almost all birds of the same feathers, right? They might not be the exact same bird, but they are similar. So then they tend to stay together. That's what we say of friends. So I want you to think of carboxylic and esters as friends. I want you to think of aldehydes and ketones as friends already as we are looking at them, because as we are just looking at the structure of their functional group, we are noticing that they have similarity. So think of them as friends for now, and we'll talk later on about what does that friendship means and what does it entail, and what then do we name it, because that friendship is given a certain name. Okay, so those are homologous series. How many are there in total? There are 9. So we have 9 homologous series in total, and it's not a big number. It's not difficult to memorize. So even though it's not done, because this has been taken directly from the examination guideline, as I always want to stay within the examination guideline, I have my way of representing them for me to remember them easy. I call them R5 catch. Those are my 9 homologous series. I just simply call them the R5 catch. That's what I call them. I say it's the R5 catch. What do you mean about the R5 catch? I know the first 5. That's how I arrange them, because I know in whatever order I arrange them does not matter, as long as I know them and I know how to identify them. So I arrange them according to this, to say the first 5 are going to be what? Starting with the letter A. 1, 2, 3, 4, 5. So that's the first 5. And the next just simply becomes catch. So I call them the R5 catch. Simple enough for me, right? I know other people will use different weight. So for me, I just go for R5 catch. So then I know that the first 5 start with the letter A, and then the last start with the letter K, E, C, and H. And now my job is to just remember, what is that letter A? Well, the first one must be alkane, the next one must be alkene, the next one must be alkyne, the next one must be alcohol, the next one must be aldehyde, and then K must be ketone, and then E must be esters, and then C must be carboxylic acid, and then lastly it must be haloalkanes. Very simple for me to remember. Simply call it the R5 catch. So I don't like the way that this structure in the exam guideline has been written. They've mixed them. For me, I don't like it. And I still, with my R5 catch, I still keep the aldehyde next to the ketone, so making them the friends next to each other again. And I still keep the esters next to the carboxylic acid, and friends are still again closer to one another. So my R5 catch, I believe it's fine. Simple to remember, because once you think of 9 homologous series, it starts becoming scary. You start thinking you're not going to remember all of them. It's not that difficult. Just call them the R5 catch, and they are just going to come to you very, very easy. Or the R5 catch. But you need to practice this grade 12. You can't just say R5 catch. If you don't practice, you are going to forget these words. Remember, these words, you are hearing them for the first time, right? If not for the first time here, for the first time this week, when your teachers were introducing them. So you haven't been with them for more than a month now. So they are relatively new to you. So it's important for you to just repeat them over and over again. Then it's going to help them start. You'll say R5 catch. What does the R5 catch stands for? Alkane, alkene, alkyne, alcohol, aldehyde, ketone, esters, carboxylic acid, and haloalkane. None of us were born knowing all these things. It's important for you to sit down and do the practice work. Okay, so I hope this makes some sense, and I hope this helps us in identifying the homologous series to which these carbon chains that we were talking about are going to be belonging. So each homologous series will have from 1 up to 6 carbon chain. Okay, I hope that makes sense. Each homologous series will have 1. So within the alkanes, we're going to have 1, carbon 2, carbon 3, carbon 4. Well, some of them it's impossible. They will have 4, some will have 5, some will have 4, right? Because some of them is impossible that they will have 1 carbon. You will see as we move on. Each homologous series will have its own chain, and the chain maximum number will be 6 carbons. Okay, right. Okay, now this brings me to the next point now. Okay, what is then important when it comes to these homologous series and functional group? Well, it is important that we can draw structural formula, or we can write a molecular formula, or we can write a condensed structural formula of these carbon chains under these homologous series and using these functional groups. So there are three types of formula that we need to be familiar with for all homologous series, and they go as structural formula, molecular formula, and condensed structural formula. This grade 12 is the most important. I don't care who says what, when. This one here is the most important. It is extremely important that we are able to do structures, because from structures we do molecular, from structures we do condensed, from structures we do names. The structures are the first and most basic things. So that's why today, for today's lesson, it's not going to be a lot of speaking from my part. We are going to be doing a lot. We are going to be drawing or writing these structures, because structures, they become, I need you by now, if you haven't done this, after this lesson, I want you to draw all structures from alkanes all the way to haloalkanes, all of them, starting from the first, the simplest structure of the homologous series, to the hardest structure. The simplest being maybe carbon number 1, the hardest being carbon number 6. And I want you to do what I'm going to be doing. You will draw that structure. From that structure, you will write a molecular formula. From that molecular formula, you will write a condensed structural formula. But the first thing that you do is draw a structure. Structures are important. Structures are the most important to understand organic chemistry. Then from structures, we can say we are doing molecular formula, right? And once we do molecular formula, then we are going to say from there, then let's do condensed structural formula. So we're going to be doing that a lot in today's lesson. So I'm going to just take one example and I'm going to show how do we draw a structure, right? Then we're going to be using these carbon-carbon chains. Then we're going to be using these functional groups. Then we're going to be then drawing or coming up with a molecular formula. And from coming up with a molecular formula, we then come up with a what? A condensed structural formula. We are going to take it one by one, and we'll try to do all the homologous series. Okay, right. Let's start with the first one. Okay, right. Here they are saying write the structural formula, right? A molecular formula and condensed structural formula for an alkane with 5 carbons. Okay, for an alkane with 5 carbons. So we are supposed to write a structural formula, a molecular formula, and a condensed structural formula. That's the order in which I want you to always do them. Always do structural, always do molecular, and always do condensed. That way, this thing becomes second nature to you. It becomes extremely easy. So they're saying it's a 5 carbon chain. And what is the 5 carbon chain in terms of the names? It is what? Pent. If you haven't forgotten those names. So this is a pent that we are talking about. It will be a pent something once we start doing the actual names of these organic compounds, right? To be actually pentane for this one. But maybe you are not aware of that as of yet. Okay, so they are saying 5 carbons. So what we need, since they said alkanes, we need to think and look back and say, okay, the alkanes, what is their functional group? How do I see that they are alkanes? I see them once they have what? Single bonds between the carbon atoms, and the only other atom they are bonded to is hydrogen. So the structure that I'm going to have here must have single bond. It must consist of 5 carbons, pent, okay? Then from there, it must have single bonds between all these carbons, and then the only other atoms that are going to be there are hydrogens, okay? Then how will I ensure that I draw the same structure that will be drawn by someone who was not here when I was giving this question? I follow the simple rules. Carbon must be happy. If I follow that, the number of hydrogens will be the same for everyone. Carbon must be happy. So let's start. Pent is going to be 1, 2, 3, 4, 5. It's 5 carbons. Okay. Then because it's alkanes, there will be a single bond between all those 5 carbons. Then from there, the only other atom that will be there is hydrogen. and all my carbons must be what? They must be happy. Okay, so I make all carbons. It is a common mistake, grade 12, to write these lines and you forget to include the hydrogen. Try to ensure that this mistake does not happen. Make sure that this mistake does not happen, because these mistakes cost us a lot of marks when we are writing our final exam. People who mark and paper 2, they always complain learners are forgetting to write all the hydrogen. Learners are not writing enough bonds for a carbon. Remember, carbon is happy when carbon has 4 bonds. 4 bonds for carbon. Please give carbon his or her 4 bonds. Please make carbon happy by giving him or her 4 bonds. Always 4 bonds around carbons. And then you indicate all the hydrogens. So this would be the correct structural formula that we are looking for in this case. And then from there, once you have the structure, the rest becomes simple, because now I do the molecular formula. How do I do the molecular formula? Well, the molecular formula in this case, I just need to go and count the carbons. How many are they? 1, 2, 3, 4, 5. I write C5. This 5 indicating that I have 5 carbons, right? And then from there, I go and count the hydrogen. How do I count the hydrogen? I physically count the hydrogen for now. Okay, so I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So it is H12. This becomes my molecular formula. I want you to physically count. And I'm aware that some of you might be aware of a general formula. I want you to start by physically counting. Physically count the hydrogens and do the molecular formula correct. Okay, then from there we are asked to do a condensed structural formula. And how do we do a condensed structural formula? Once we have a structural formula, it becomes again easy. All we do for the condensed, we try to mix molecular and structural, but omit the bonds. So we omit those lines that are showing the bonds. That's how we just do when we do the condensed structural formula. So what we do here, we are going to say, let's look at the first one here. How many hydrogens is it bonded to? It's bonded to 3. So let's omit all these bonds and write them in terms of CH as if it was a molecular formula. So it's going to be C bonded to hydrogens. How many of them? 3. Okay, and then here we're going to come here and say we have another C. Now we're no longer indicating the line there, even though in some of condensed structural formula they do indicate it, but in some they don't. In most cases they do not. So expect that it's not going to be indicated. So you're going to have H here, and then you have 2. The 2 indicates there are 2 hydrogens. Okay, then you are going to have H here, you have 2 again. I've done the C, the first one here was CH3, the second one CH2, the third one must also be CH2, the fourth one must also be CH2, and the last one is going to be what? CH3. This becomes a condensed structural formula. Okay, it could be complicated, okay, which I don't want us to focus more on. It could be complicated, or they could write it like this and say CH3, right? Because now I'm noticing that I have 1, 2, 3, 4 CH2 all bonded to each other directly, by the way, directly bonded to each other. I can simply open a bracket and say I have CH2 and I have 1, 2, 3, 4 of them. Then I have a CH3. Okay, I think this will bring a question to a learner to say, well, why don't I do the same for CH3? Well, I can't, because CH3, this CH3 is not directly bonded to this CH3. So I can only do these ones because they are directly bonded to each other. So, but which one would I prefer you do if you were ever asked for the condensed structural formula? Grade 12, let us not complicate our lives. Let's stick to the basic and most simplest thing. Do this one and you are going to be fine. But you can also understand this one because it will help you a lot. Okay, now grade 12. This one I want you to try yourself. I am going to give you 3 minutes and then you are going to draw a structural formula. You are going to write a molecular formula, and you are going to try and do a condensed structural formula for an alkene with 3 carbons. Your 3 minutes starts now. All right. I hope you've tried this activity, and I hope we're winning. Let's check if you have done it correctly. Okay. They're saying write the structural formula for molecular formula and condensed structural formula for an alkene with three carbon chain. Okay. So we know that 3, according to our new numbers, is prop. Okay, very important to always remember this, because these questions are not always going to be asked like this. They are just simply asked like this for now because we are unfamiliar with these prop build things yet. But these questions are from today, or as we move on, we're going to be saying prop, build, pent, right? So it's important to remember that 3 carbons is prop, and we are doing an alkene. So how do I identify an alkene? I identify an alkene by seeing a double bond between the carbon atoms. So what I will do here, I need 3 carbons. 1, 2, 3. And in those 3 carbons, I need what? A double bond. And I hope grade 12, none of you put a double bond here and here. That will be wrong. Okay? We do not do more than 1 double bond. So we only have only 1 double bond in a chain or per chain, right? If we are having a double bond, it's only 1 double bond per chain, only 1 triple bond per chain. And we are never going to have double or more than 2 double bonds. We are not going to have 2 triple bonds, and we are never going to have a double bond and a triple bond. So it's only 1. So either the double bond, you put it here, or you put it there. It's all going to be the same. So it's a double bond here, then here it must be a single. So this becomes an alkene. Why does it become an alkene? It has a double bond in at least one of the carbons. Okay, but if you remember again, we said carbon must be happy. How do you make carbon happy? You give carbon 4 bonds. Always give carbons 4 bonds. So already this one has 2, so it just needs what? 2 more. Okay, what about this one? 1, 2, 3. Already has 3. You can give it 1 more. What about this one? It only has 1, this one, so it needs 3 more. So it looks like this. We said it's a double bond, and the other atom that can be there in an alkene is what? Only hydrogens. Why? It's a hydrocarbon. It is containing hydrogen and carbon atoms only. Very important, that only. Okay, so from there, we want now a molecular formula. This would be its structural formula. If you have your double bond this side, that means you will have 2 hydrogens this side and 3 hydrogens this side. It doesn't matter where you put your hydrogen, your double bond, I mean in this case, okay, as we are still just drawing generally, okay, it will matter as we dive into the names, okay. It also doesn't matter here where we put the hydrogen. As you can see here, I've drawn the hydrogen on top. I could have well as drawn the hydrogen here at the bottom. Okay, so let's get the molecular formula. The molecular formula will say how many carbons do I have? 1, 2, 3. So that's C3. Okay, and how many hydrogens do I have? Manually count 1, 2, 3, 4, 5, 6. Then it becomes H6. Okay, and if you do all alkenes, all of them one by one, you would start to notice that all of them, they differ by a CH2 group. So all alkenes starting from 2 carbons, 3 carbons, 4 carbons. And by the way, I have to say this, I hope everyone can see that it is impossible to have an alkene with 1 carbon. Because for me to see an alkene must have a what? A double bond between 2 carbons. So that means the chains for alkenes, they only start from what? From 2 carbons. I cannot have an alkene with 1 carbon. I hope all of you grade 12 can see that the simplest alkene will have 2 carbons. This will be the simplest alkene. It is impossible for me to have an alkene with 1 carbon. Something just to keep in mind. Okay, then let's have the condensed structural formula here. It's condensed structural formula, and by the way, when we do the condensed structural formula, we always start from left to right as we read. That's a rule. It is a rule. Always the condensed structural formula always starts from left to right. I can't start here and then write CH3. No, that would be wrong. Always start from left to right. So in this case, I will be having CH2 because I have a carbon with 2 hydrogen. Okay, this carbon with 2 hydrogen is bonded to a what? A CH. Okay, this is the CH we are talking about, and this one is bonded to what? To a CH3. So we just simply omit these bonds. However, I will say again, sometimes you will find the double bonds being indicated in the structure, in a condensed structure formula. It is not often though that happens. So sometimes they will indicate CH2 and then indicate a double bond and then CH3. So sometimes the condensed structural formula will be represented like this, where they actually represent the bonds. So, but again, I'm not too fond of this one and I'm not a fan of it. I'm a fan of this one because this one comes directly from my what? From my structural group, because it means if I know how to take it directly from my structural group, then it means I know how to take it from condensed back to the structural group, because that's again the most important thing. I must be able to go forward and in reverse. Okay, so as we continue with the activities, because I want to cover all the homologous series and show how you draw using its structural functional group, I will go straight to alkynes. It says write down the structural formula, molecular formula, and condensed structural formula for alkyne, for an alkyne with a 4-carbon chain. What is 4-carbon chain? That's bute. Bute is 4. Must always remember that. So it's carbon chain. It's an alkyne. How will I know that I'm talking about an alkyne? That means I must have a triple bond. Only one triple bond per chain. So it will be 1, 2, 3, 4. Then I can put a triple bond. That's for simplicity. Put the triple bond here on the first carbon. And then let's have single bonds. I cannot have a triple bond here, triple bond here, triple bond here. How would you get? We can't have that. It can only be one triple bond per chain. Okay, so then from there I make my carbons happy. The issue of making carbons happy is very, very important. Grade 12. That's how I say it. That's how it makes sense to me. Carbon must have 4 bonds around itself. That's what I call it. I call it making the carbons happy. When is the carbon happy? When carbon has 4 bonds. So 1, 2, 3, 4. This one is already happy. So that means I cannot be adding hydrogens here. I hope everyone can see that. I can't put hydrogen here because this carbon already has 4 bonds. Once I put a hydrogen here, it becomes 5 bonds now, which would be incorrect. What about this one? 1, 2, 3. It is only short of 1 hydrogen for this one to be happy. Let's quickly write its molecular formula. Its molecular formula will be, how many carbons are we dealing with? 1, 2, 3, 4. So it will be C3 and then 4, C4, sorry, C4. Okay, I counted 4. 1, 2, 3, 4. And then we're going to have 1, 2, 3, 4, 5, 6 hydrogens. Then it will be H6. Now we have the structural formula. We have the molecular formula. We now need the condensed structural formula. Condensed structural formula. It's a structural formula that has been condensed. You just simply what? You omit the bonds. Then you have your condensed structural formula. Always starts from left to right. So we are going to have CH. And then this CH is bonded to a C, which is bonded to a what? A CH2. And this CH2 is bonded to a CH3. That's my condensed structural formula. It is extremely important, creature, that we always start with a structural formula. The structural formula will always make your life simple. So it is important that you familiarize yourself with the structures, familiarize yourself with the functional groups, because you are not going to be able to draw a correct alkyne if you don't know the functional group of alkyne. If you don't know that for me to say this is an alkyne, I must look for a what? A triple bond. If you don't know that, you won't be able to draw a correct structural formula. That means you will never get a correct molecular formula. That tells us that you are never going to be able to do the correct condensed structural formula. Okay, the next one again. It's important for us to do over and over again, and I hope everyone is doing with me as we are working there. As I am doing, you're also doing, and we are checking each other as to we are going in the right direction. Activity 4 says, write down the structural formula, molecular formula, and condensed again for an alcohol with a 4-carbon chain. We are looking for an alcohol. So we are going to go for the simplest carbon. It says 4, so that means it's again what? Bute. Just reminding that 4 means bute, because the next time we talk about these things, I will not be saying a 4-carbon chain. I'll be just talking about bute pent. Okay, so the 4-carbon chain, the chain is going to be consisting of 4 carbons. 1, 2, 3, 4. Okay, what bonds, type of bonds should these carbon have? These carbon can only have single bonds because they cannot have double bonds. Once they have a double bond in between them, they will be confused for an alkene. This is for our level grade 12 technical science. So we cannot have a double bond here. As I've said, organic chemistry can be very broad. Maybe at higher institution that may be the case, but here it's never going to be the case. We cannot put a double bond between these between any of these carbons, since we are saying we are looking for what? An alcohol, because immediately we see a double bond, we should be able to relate it to alkenes. So the only bonds that must be there are single bonds. Okay, then how will we identify that this is an alcohol? Structurally, an alcohol is identified by a hydroxyl group. If you remember, the O bonded to the H. Okay, and this O must be bonded to one of the carbons. And for simplicity, I'll put it here. I'll put it here as O bonded to OH. And it is important that the bond between the O and the H is indicated, grade 12. You must always, when you draw or you write a structural formula, it is important to indicate the bond between the O and the H. Let's not make this mistake that I'm not even going to write here because I don't even want you to see it. I will only speak about it, the O and the H without the bond between O and H. Let's not do that. Let's indicate the bond between the O and the H. Okay. Then from there, what do? We make sure that all carbons are having 4 bonds. All carbons are having 4 bonds. Okay. And I put what? Atoms there. I put hydrogen. Okay, does this still become a hydrocarbon? The answer to the question is no. This is no longer a hydrocarbon. It might be having a lot of hydrogen, it might be having carbons, but it's not only hydrogen and carbon atoms. There is also an oxygen atom there. So this is not a hydrocarbon. It's just an organic compound belonging under the homologous series, alcohol. So it will look something like this. So let's quickly write the molecular formula there. 1, 2, 3, 4. It will be C4. And then hydrogens 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10 and O. This is how I want you to write the molecular formula, even though I am aware that other people would write it C4H9OH, which is also fine. So these are 2 ways in which you can write this molecular formula. However, I prefer this one most of the time. Then condensed structural formula here, we will say CH3. I hope everyone is now moving with me easy. CH2, CH2, and then CH2OH. It is important that we represent it as OH. We don't say CH3 because this H is not directly bonded to this carbon. Okay? I hope you get me here as I move. Okay, then now we're going for aldehyde. Our aldehyde must have how many carbons? 3 carbons. Okay, 1, 2, 3. It is simply supposed to be single bonds. It can't be double or triple because that will be confused with alkene and alkyne. Okay, and then we said for aldehyde, we must have a double bond O on carbon number 1. O double bond O on carbon number 1. So I will put it here, double bond O on carbon number 1. Immediately I see this, and then to complete it, then it's going to look something like this. Then all carbons have 4 bonds by having those hydrogens. 1, 2, 3, 4. Just making sure everything is correct there. The molecular formula would be 1, 2, 3. Okay, hope everyone is getting a hang of this here. Okay, and then we're going to have hydrogens. How many? 1, 2, 3, 4, 5, 6, H6, and an oxygen. Okay, right. Condensed structural formula would be CH3, CH2, and then CHO. Okay, I hope you can appreciate the difference here. On the previous one, it was C and then there was OH at the end. But to differentiate an aldehyde from an alcohol, this one we represent it as what? CHO. It brings the difference between an aldehyde and a ketone, an alcohol in the condensed. Let's try for a ketone quickly. For a ketone, they say the simplest ketone. The simplest ketone could only be what? 3 carbon ketone. Why? Because it is impossible to have a double bond O between 2 other carbons if it's not 3. If it's 2, it will become an aldehyde. So these 3 becomes the simplest ketone. Single bonds. If you move this here, becomes aldehyde. You move this here, becomes aldehyde. So this becomes the simplest. If you don't put this one here, this one is eliminated, again it becomes aldehyde. The simplest ketone can have or will have 3 carbons. It has to have 3 carbons. Molecular formula here is C3, H1, 2, 3, 4, 6, and O. And then this condensed CH3, CO, CH3. Then you have the condensed structural formula. Simple as that. We move on to the next one, 7. Write the molecular formula, structural formula and condensed for the simplest ester. Again, the simplest ester could only have 3. The simplest ester could only have 3 because it must be surrounded by the carbon with a double bond O must be surrounded by. Then we make these ones happy. This one is okay. Okay, it will have. This one is also okay. Now, this one is also okay. 1, 2, 3, 4. The molecular formula for this one, C1, 2, 3, 2, 3, H, 1, 2, 3, 4, 5, 6, H6, O2. This will be the molecular formula. Let's do the condensed structural formula for an ester. It will be CH3, and then it will be C bonded to O, bonded to another O. Then this O will be bonded to CH3. Again, I hope you get what I'm trying to do here. From the structure, we can be able to do all these things. They do not become complicated. Carboxylic acid, 6 carbons. 1, 2, 3, 4, 5, 6. On the first carbon, I always make this one the first carbon. They must be a double bond O with an H. That's how we said we see a carboxylic acid from that table, if you remember, of our homologous series. It has a double bond O, and an H. And then the rest of the carbons must simply be made happy by making them have 4 bonds. We have spoken a lot about this bond issue of the carbons. Okay, and then molecular formula there would be C6, H, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. H12, and then O2. Condensed structural formula, CH3, CH2, 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 COOH. Very, very simple there, grade 12. Okay, the last one, I'll leave it to you to do again as your activity for the day. You are to write a structural formula, molecular formula, and condensed structural formula for a haloalkane with a 4-carbon chain, and I want this haloalkane to be bonded to a chlorine, only one chlorine atom. And I want you to draw a structural formula from there, and from there I want to do a molecular formula, and I also want you to do a condensed structural formula. With that being said, grade 12, I hope you've gained a lot from this lesson. Thank you.